In this video, I'll be reviewing how to graph a piecewise defined function. So here we've got our coordinate plane set up and we have a piecewise function, f of x equals x minus 5 when x is less than or equal to 0, x cubed when x is greater than 0 but less than or equal to 2, and 2 over x when x is greater than 2. So what I recommend doing for these examples is making a table. So in our table, we're gonna make a table for each of the functions based on their domain. So if we look at x minus 5, I know that this is going to be when x is less than or equal to 0, so I can just pick a couple points that are less than 0. So you've got -2, -1, and then of course 0. One thing that can be helpful is recognizing since it's greater than or equal to 0, this is going to be a solid point, and so are these if you'd like to. You could even say it's going to keep on going since it's less than. The next equation, we're going to have this restricted domain, so x cubed So when I'm choosing my x values again, they're going to be 0, 1, and 2. And because it's greater than 0, it's going to be an open circle here, but it's going to include 1 and it's going to include 2. So putting these little marks here can just sometimes help you not make that silly mistake. And then the last equation is 2 over x, which is when x is greater than 2, so we're going to start at 2, and then we could go on to 3, 4, 5, 6, and then it's going to keep going. But we know it's going to be open here, and then these are all going to be filled in. So what I'm going to do now is just determine what my y values are for those corresponding functions. Sorry, color. So for the first one, x minus 5, if I substitute in -2, -2 minus 5 is -7. -1 minus 5 is -6, and 0 minus 5 is -5. We could even just go ahead and start graphing this. So it's going to be filled in at 0, -5. And then we have a point at -1, -6, and -2, -7. So now what's important is before you make your line, you need to look at the actual function. So because this is x minus 5, we do know that it's going to be a linear function. So we can just take a ruler, which I don't currently have, so bear with me, and connect these. And I'm going to put an arrow on it because I know it's going down infinitely. Now if we look at our next function to fill in the rest of our table, x cubed, 0 cubed is 0, 1 cubed is 1, and 2 cubed is 8. So I'm going to plot those points 0, 0, and this is where making that open circle right here can be helpful. Just a reminder that it is open at the origin 0, 0. And then we have the point 1, 1, and 2, 8. So what we need to do now is just confirm our function. So it's going to be x cubed, which if you remember, it's a graph that looks like this. And so based off like how our curve is, it looks like we're coming after that little turning point. So this should have a nice little curve, and then it just stops. For our last function, 2 over x, remember this is rational, so 2 divided by 2 is 1, 3 divided by 2 is going to be just 2/3, or you could say 0.6 repeating. For these tables, I don't really care if you use fractions or decimals. 2 over 4 is 1/2, or 0.5. Oops. 2 over 5 is just 2/5, or 0.4. And 2 over 6 is 1/3, or 0.3. And then if you wanted to, you could remind yourself that it's going to keep going. So I'm going to plot these points now. Remember, open circle at 2, +1. And then we go down to 0.6, 1/2, 0.4, 0.3. So remember, this is a rational function, so it's actually going to have an asymptote on the axis. So it's never going to intersect, so you can make it look like it's getting really, really, really close to the x-axis, but don't go past. And this is our final graph. Hopefully yours looks a lot better because you're not writing on a surface, but that's the gist.